In the previous video, we looked at how redirect or open redirect attacks happen, and now with a very exemplified example, if I can put it that way. And now let's see how a blue team or a defensive approach works when it comes to preventing malicious redirects. Now, the risk of this type of attack is the prevalence is pretty common, the exploitability is relatively easy, and the impact is worrying, so it doesn't have that big of an impact. But of course, if you chain it, if you're a red team or a cybersecurity professional, a pen tester, or an application security professional, you might be able to chain this attack with other attacks and increase the impact. So from worrying to very harmful or even devastating. If your site permits open redirects, you may be unknowingly helping attackers take advantage of your user base. So redirects are a useful function to have when building a website. As we've seen in the login feature previously, if a user attempts to access a resource before they are logged in, it is actually very conventional to redirect them to the login page, put the original URL in a query parameter, and after they have logged in, automatically redirect to their original destination, which I believe as application security professionals, we've seen this time and again. This type of functionality shows you are putting thought into user experience and is to be encouraged. However, you need to be sure that wherever you have redirects, they are done safely. Otherwise, you're putting your users to jeopardy, such as phishing attacks. Modern webmail services are very good at spotting spam and other types of malicious messages. One detection method they use is to parse the outbound links. So these links are compared to a blacklist of banned domains. Like for example, Gmail, they probably maintain a huge blacklist of banned domains. So if the domain is deemed to be malicious, the email is redirected to the junk folder. This is probably one of the reasons spammers and phishers find open redirects so enticing, because if they can bounce the user off your website and to a valid domain, off your website, which is a valid domain, their messages are less likely to be marked as malicious. So if the user clicks on the link, they will see your website in the link, but they will end up whatever site the attacker wants to redirect them to. Now, a confused user might download malware or worse because of the trust they put in your website. How do you protect against open redirects? Disallow off-site redirects. You can prevent redirects to other domains, so whatever redirects you have, you make sure that are on-site or on-domain or belonging to the same or to the subdomains. But if you allow redirects to subdomains of your domain, there are circumstances when that can be tricked, or your blacklist or your allow list can be bypassed, or your rejects can be bypassed. So you have to make sure that disallowing offsite redirects, you're actually implementing that accordingly by checking the URL being passed to the redirect function. So make sure that all redirects URLs are relative paths, not absolute paths. So they start with a single character. Note that URLs start with http:// will be interpreted by the browser as protocol agnostic. Absolute URLs, so they should be rejected. If you do need to perform external redirects, you should probably maintain a whitelist to the individual sites that you allow redirects to happen. So better have whitelists if you're doing external redirects. If you're redirecting internally, you use relative paths. Check the refer when doing redirects. Redirects to URLs passed in query parameters should only be triggered by pages on your site. So if another site triggers a redirect, any other site triggering a redirect should be treated with extreme suspicion as a second layer of defense. Check that refer in the HTTP request. So let's see if we can look at it here in developer tools. So they say that check that the refer matches your domain whenever you perform a redirect. So for example, let's see if we go to google.com. We'll look at actually all of them. So the idea is not to google.com, but to actually refresh the page here. Hopefully this doesn't impact our progress. We can see that we have a lot of, in the network tab, we can see if we click on all of them, we can see that we have a lot of requests. Let me actually maximize this. So for example, the request to open redirects here, there is in the request headers, there is a refer here. As you can see, there is a refer. Now, back to our, let me just, any other site. So as a second layer of defense, check the refer in the HTTP request matches your domain whenever you perform a redirect. So that refer over there, if we refresh, that refer is actually matching. So you should do some sort of a regex on the refer over here. But make sure that you are aware of the fact that regexes can be exploited as well. So you have to write it and actually test it appropriately so that you are sure that it cannot be abused. Code samples. So in Python, how to check that a URL is a relative path. So you're using regex in Python. This is the regex code to actually check that a URL is a relative path. So you're using regular expressions. This is the expression. You start with the R, which is the raw, I believe, in Python, and then your expression. Ruby, something similar, just that you create a function here is relative URL, and in this situation, I'm not actually, I don't code in Ruby, so I see that there's no importing. Maybe this is just a built-in feature. In Java, here's an example of a redirect that's open to abuse because the get parameter URL is not validated, but so you're not doing, you're just checking if it's not null, but in this situation you're actually validating it appropriately because first you're actually defining the URL, then aside of the fact that you're checking whether or not it's null, you're actually looking whether or not it is a relative URL, and below you define what that is on a function. So it's basically the same thing across multiple languages. You're actually checking whether or not the URL is a relative path. .NET, the implementation in .NET, and of course probably one of the most popular implementations is in Node. Defining a function and URL matches this. As we've seen, it's similar to Ruby. Other considerations, so check client-side code too. Redirects can happen in client-side JavaScript. So you need to validate any code that sets window location to ensure the URL is not taken from untrusted input. Interstitial pages. This is what I was telling you about in the previous video. Some sites, so in the attack video, some sites insert interstitial pages when the user is leaving the site. And I'm sure you've encountered this because remember, when you've seen a message like you are now leaving this, you will be automatically redirected in 5 seconds. So this is actually the website informing you that you're leaving. So it's actually interstitial. It actually interferes sort of like with your source website and the destination website. It actually brings you clear awareness that you're actually leaving the source or the source website, and it tells you that you will be redirected to whatever. Aggregator sites often make use of redirects to click counting. URLs are chosen by the community, then a user clicks on the link, the click-through count is incremented, and the user is redirected to their destination. So if your site implements this type of functionality, redirects to externals are part of doing business, just make sure you check the refer each time you do a redirect. So you check the refer as I've shown you previously. Further reading, what is an open redirection vulnerability and how to prevent it? This is a blog from NetSparker. Now let's actually test ourselves. What is phishing? Tricking users into clicking on malicious links in emails. Where might a redirect occur in your code base? When navigating to a site on another domain, immediately after login, when the user clicks on a link going to somewhere else on the same site. So I am inclined to click on this one too, but let's actually leave the immediate after login. Both are correct. Alright, so this was open redirects in a very sort of like short nutshell. Next, we're actually going to look into unencrypted communication, and you would be surprised how often that this type of vulnerability or issue or security issue still occurs in 2022.